Hi, everyone. Thanks so much for being here with me. I am so excited to get to be with you all here in Amsterdam for our first ever Rails World. Today, I will tell you the story of how we migrated from MySQL 2 to Trilogy in Shopify's largest Rails codebase, and a little bit of how we added support for Trilogy to Rails for the 7.1 release. Before we get started, let me introduce myself. My name is Adrianna. I'm a senior software engineer, and I work for a company called Shopify. Shopify is one of the founding core members of the Rails Foundation. We have a booth here, so come check us out. We are an e-commerce company. We offer a variety of products for online and in-person retail. And I currently work on a team called Scalable Rails Apps. So our job is to ensure that Shopify's Rails applications are using Rails the right way, that our applications are easy to build, maintain, and refactor. So we make sure that Shopify apps use Rails the right way, and that Rails continues to evolve to meet Shopify's needs. I'm based in Ottawa, Ontario, in Canada. Outside of work, yay! Outside of work, I like to cycle, I like to hike, spend time outside. Like to spend time with my dog. This is my dog, Jasper. He's a Roddy. He is a big sweetie, love him a lot. He keeps me busy. So a little bit more about my background. I've been working with Rails since starting at Shopify in 2016. I started as an intern right out of high school and worked there while I got my computer science degree at uni. I'm one of the maintainers on the Trilogy project. I'm currently a member of the Rails issues team. And I am really passionate about open source software and about making the Ruby and Rails communities more diverse and inclusive. One of the things I'm really excited about is being a part of our WMB.RB community. This is a community for women and non-binary Rubyists. We hold virtual meetups once a month. We have a Slack workspace. It's really great. And WMB.RB is actually having a breakfast sponsored by Shopify tomorrow morning from 8 to 9:30. I know that's kind of early, but please come. If you are a woman or non-binary individual, please come join us for breakfast. Please come say hi. Okay, so today we are going to be talking about Trilogy. If you've never heard of Trilogy before, don't worry. We will start with an overview of the Trilogy database client. I'll talk about what makes Trilogy different and why you might want to switch. Next, we'll go over some of the changes we needed to make to our code base at Shopify in order to switch from MySQL 2 to Trilogy. Then we'll talk about how we deployed a large change like this to production and what some of the results we saw were. And finally, we are going to talk a little bit about the process of upstreaming the Trilogy adapter to Rails for 7.1. We are going to use this analogy of climbing a mountain to talk about the journey we embarked on while trying to migrate from MySQL 2 to Trilogy at Shopify. Our goal was to run Trilogy in production. That was our summit. But the path up was not very clear. We weren't sure what incompatibilities might exist between MySQL 2 and Trilogy, or what risks there were to consider. Where did we even start? It became clear that before we could start our trek up the mountain, we needed to get out a metaphorical map and grasp the lay of the land. So that is where we'll begin our story today, gathering our bearings a little bit by learning about the Trilogy database client. So what is Trilogy? Trilogy is a MySQL database client written in C with Ruby bindings. A client is any program that can communicate with the server and issue commands. Trilogy was open sourced by GitHub in 2022 alongside an active record adapter. Matthew Draper from GitHub wrote a wonderful blog post about it for GitHub's engineering blog. I will link it at the end of the slides. If you're interested in Trilogy, please do give it a read. The neat thing about Trilogy is that it uses a custom implementation of the MySQL network protocol. Most client programs rely on libMySQL client, a library distributed with MySQL in order to talk to the server. For example, MySQL 2, very popular MySQL Ruby gem, links against libMySQL client. But Trilogy does not depend on libMySQL client. It defines its own low-level API in C for communicating with a MySQL server. And it is entirely self-contained with no external dependencies other than like POSIX and OpenSSL. Trilogy supports the most frequently used parts of the protocol, including the authentication handshake and the ping, query, and quit commands. And overall, Trilogy is designed for flexibility, performance, and ease of embedding. So why would you want to switch to Trilogy? One of the biggest reasons is that, as I just mentioned, there are minimal dependencies required for compilation. There is no dependency on libMySQL client or the similar libMariaDB library, which means that it is going to be simpler to install. You don't need to install and link against the libMySQL client library. You don't need to deal with compiler flags. It can also eliminate client-server version mismatch issues. Using a different libMySQL client version compared to your MySQL server's version can cause issues. This is something that we were running into a lot at Shopify, and that made it hard for us to upgrade MySQL versions on our servers. So Trilogy sidesteps all of this by avoiding that libMySQL client dependency. And then it can also improve memory usage because it minimizes the number of times that data must be copied when handling network packets, which improves memory usage. Trilogy is also designed to perform efficiently in the context of the Ruby VM. It is conscious about its use of dynamic memory allocation, and the API is designed to use non-blocking operations and I/O callbacks where possible, which makes it faster in a language like Ruby. There are, of course, some caveats to switching to Trilogy that you should be aware of. One of the big things is there are still some incompatibilities with MySQL 8 related to authentication plugins. If your application is already on MySQL 8, this might be something to consider. It's something that we're looking into. It might not be as feature complete as MySQL 2 and libMySQL client. So if your application is using a lot of custom database configurations, you might want to take that into account. Features such as prepared statement support are still being built into the Ruby driver. And then finally, it is a fairly recently open source library. The documentation is perhaps not as robust as other client library options. There's also just not that many applications using Trilogy in production. Shopify is now using it, and GitHub has been using it for a while. So those are two pretty big Rails apps that are using it very successfully. But there might be features that are missing because none of the existing applications needed those features. So do consider giving Trilogy a try in your application, and it's open source, so consider contributing to open source if it's missing something that you need. So why did we want to make the switch at Shopify? There were a couple of things we were hoping to accomplish. One of the biggest reasons was better developer experience. We were experiencing a lot of compilation headaches with MySQL 2 and its dependency on libMySQL client, especially on macOS. Our hope with Trilogy was that it would greatly simplify the process of getting a Rails app booted locally with a MySQL database. We were also hopeful of speed-ups in query performance. Everyone likes it when things go faster, right? So, Trilogy was making claims that it would be faster in Ruby, so we were excited to see if that was the case for us. And then finally, we were really keen to move to a library with a strong sense of maintainership. Not only does Trilogy have a number of active contributors, but we had several engineers at Shopify who had worked on the library while at GitHub and could offer their support and expertise. And all along the way, we kind of had this loftier target in mind. Aaron Patterson and Eileen Ushitel were the original advocates for open sourcing Trilogy while at GitHub. Now they work with me on Shopify's Ruby and Rails infra team. So if we managed to adopt Trilogy at Shopify, they were confident that we could make the case to upstream the Trilogy adapter to Rails. This would result in bigger maintainership for Trilogy. So we were really excited about the possibility of making Trilogy a Rails community standard. In other words, we realized that although our initial goal was to just run Trilogy in production at Shopify, we were actually trying to reach this bigger peak of upstreaming Trilogy support to Rails and trying to make it a community standard. We still needed to start with small steps, though, and try Trilogy out in our Monolith. If you're thinking about moving to Trilogy in an existing Rails app that uses MySQL 2, here are the steps we took and some of the things that you should watch out for. So step one is to set up your application to use Trilogy. We needed to install the gem for the Trilogy client, as well as the gem for the Active Record adapter. At the time, the Active Record adapter was a standalone gem. The adapter was upstreamed as a part of the Rails 7.1 release. We'll talk a little bit more about the upstream process later on. But just keep in mind that you won't need to install the separate active record gem if your app is using Rails 7.1. The gem does offer support for for Rails versions earlier than 7.1, starting at Rails 6.0. So if you are not yet on Rails 7.1, but you want to give Trilogy a try, you can do so with the gem. And then we set the adapter to Trilogy in our database YAML, and that is pretty much it in terms of configuration. It's very much plug and play. There were a couple of other things to consider, though. We needed to address differences in the API when working directly with the database client or client results. Most of the time, we go through active record APIs when dealing with the database, so it's relatively uncommon to need to interact with the client directly. However, if there are places where you're interacting with the client, you'll need to watch out for some small API changes. Here's a very simple example from our application. We have a method that executes some custom SQL on the database connection and enumerates the result. With MySQL2, calling execute with the query would get you back a MySQL2 result object, and we'd enumerate the result using that each as hash method. With Trilogy, we get a Trilogy result object, and to enumerate that object as a hash, we would use the each hash method instead. So kind of a small change. Another simple example, the MySQL2 client has a query options method that exposes the options that are passed in at connect time, like when the client is initialized. We were accessing the client by using raw connection and then using that query options method to grab the host and port for the current connection to use in a cache key. Trilogy has the concept of query flags. It is a bit mask that controls options that can be set at query time, for example, things like casting options. This is not the same as MySQL2's query options. Trilogy's query flags don't have anything to do with the options that are passed in at connect time. My speaker notes disappeared, but they're back. So yes, we added a method to Trilogy that exposes the options passed in at connect time, but we ended up naming it connection options so that there would not be confusion with the existing query flags method. So if you are using query options on the MySQL2 client, you will now need to use connection options instead. Finally, we needed to address differences in the error classes. This one is pretty simple. If you're rescuing MySQL2 errors directly, you'll need to change these to rescue Trilogy's base error instead, which is Trilogy error. Trilogy overall exposes very comparable errors to MySQL2. For example, there is a MySQL2 timeout error and a related Trilogy timeout error, as well as a MySQL2 connection error and a related Trilogy connection error. The mapping should be pretty straightforward, so if you're rescuing specific errors, the Trilogy error should be similar. The error messages will differ slightly, so if you're checking explicit error messages, make sure you adjust those to accommodate Trilogy. There is one key difference in connection-related error handling between MySQL2 and Trilogy, and that is if the database is down, MySQL2 raises a connection not established error. This is a test I pulled from our Monolith. We use this thing called ToxyProxy to simulate the database being down to make sure we can test scenarios where we would want something to happen because the database was down. So here we are testing that if the database is down and we make a GET request to this endpoint, that we see this connection not established error. Trilogy, however, opts to close the connection client side if it cannot talk to the server. This means that if the database is down, Trilogy is going to surface that as a closed connection error. And the adapter translates connection closed errors to active record connection failed. That error class is just a little bit more appropriate. So this means that the error will show up in Rails as active record connection failed instead of active record connection not established. So if you're testing anything related to the database being down, some of your test assertions may need to change. The more important thing to remember though is that if you are rescuing connection-related exceptions, make sure you rescue both connection not established and connection failed, because both of those errors will be raised by Trilogy. Okay, so that was kind of an overview of some of the changes we made to our app code. To say that that was all we needed to do to migrate is a little bit of an oversimplification. There were some other significant changes we needed to make to ensure feature parity between MySQL 2 and Trilogy for Shopify's needs. I won't go into too much detail, but here are some of the other things we thought about. The first of these was making sure that Trilogy's feature set supported everything Shopify needed. One thing we needed to do was build multi-statement support into the Ruby bindings for the Trilogy database client. Multi-statement is a feature that allows you to execute multiple SQL statements in a single query command to the database. In a nutshell, building multi-statement support into Trilogy was important to us because Active Record uses multi-statement capabilities to be able to insert fixtures in bulk. Our Monolith has a lot of fixture sets. We were relying on this bulk fixture insertion to reduce the number of SQL queries to insert all of our fixtures data. I won't get into this too much. If you're interested in learning more about this work and actually kind of looking at code in the Trilogy C library and in the Ruby driver, I spoke more about this at RailsConf in Atlanta earlier this year. I'll put a link to that talk at the end of the presentation. But that was one thing we had to spend some time on. We also worked on ensuring that any patches to the MySQL 2 adapter were upstreamed where possible so that we could avoid having to rewrite patches for Trilogy. One such example is the Active Record Pedant MySQL 2 adapter. Yes, that is a mouthful. This was a custom MySQL adapter we wrote on top of the MySQL 2 Active Record adapter. Its purpose was to report SQL warnings, allowing applications to capture and fix SQL warnings progressively. The API is pretty simple for Pedant. By default, it just raises all SQL warnings as errors, but applications can fine-tune the behavior around warnings in an initializer, for example, setting custom warning behavior, ignoring certain warnings, raising and silencing warnings in certain scenarios. So rather than re-implementing Pedant to work with Trilogy, we went ahead and upstreamed SQL warning reporting to Rails. We wanted the API to kind of match the important bits of Pedant. We wanted users to be able to log, report, or raise warnings. We wanted users to be able to ignore certain warnings, and also to be able to customize warnings behavior with like a proc. So we ended up coming up with this API that was pretty simple. We went with 2 Active Record configs. One configures the action to take when a SQL warning is emitted. That is that DB warnings action config you see. It's customizable via a proc, so that's how we got the customization in there. And then DB warnings ignore is the other piece, and it specifies a list of warnings to ignore. You can ignore on like SQL error codes and stuff. So yeah, we managed to upstream that to Rails, and upstreaming it to Rails allowed us to get rid of our dependency on Pedant. And oops, sorry, we deprecated Pedant for 7.1, and the gem will be removed when a future version of Rails is released. Okay, the last thing I'm going to talk about here is ensuring parity in all of our external tooling. If your application relies on database tools or frameworks that assume that MySQL 2 is being used as the database client, make sure that you adjust these to anticipate the Trilogy client being swapped in. Here are some examples from our application. At Shopify, we use a tool called Semian for controlling access to slow or unresponsive services. This is an open source library that we wrote. It intercepts resource access and fails quickly in situations where a service is unresponsive. The database is a resource that might be slow or unresponsive, so Semian needs to intercept database calls. We had Semian code that would work with MySQL 2, but that wasn't directly compatible with Trilogy. So we ended up writing a resource adapter that would intercept calls to the Trilogy client so that we would make sure that we would fail fast with Trilogy. Semian is open source. You can take a look at the code if you're interested. I have a link at the end of the slides. If you're interested in learning more about Semian, feel free to come grab me later. Another small example is OpenTelemetry, an open source observability framework. We were using this to instrument our SQL queries at Shopify, and we were relying on the OTel MySQL 2 gem. We saw that there was a similar OTel Trilogy gem already available, but it hadn't been maintained as consistently as the MySQL 2 one. So we ended up pushing out some changes to OTel Trilogy just to make sure it was at feature parity with the MySQL 2 one. And then we were able to use it. And so if you use OpenTelemetry or you're interested in using it, it does support Trilogy out of the box, which is nice. Okay, so at this point, our CI was green. We were eager to try things out in production, but we were wary of deploying a massive change like this all at once. We needed to come up with a plan to safely roll things out. To start, we decided to run the Trilogy database client on 1% of production traffic. We did this by exporting an environment variable to 1% of our pods and then configuring the adapter in our database YAML based on whether this environment variable was set. This meant that we needed to support both MySQL 2 and Trilogy in our application code. Thankfully, this wasn't that difficult because the API is pretty similar for the two of them. But for example, anywhere we were dealing with the client API directly, we would switch on the connection class and handle those differences in the API. One question we had, though, was how do we run tests? We did not want to create a whole new CI pipeline for Trilogy because we have a very large CI suite and that was going to be very expensive. We didn't want to remove MySQL 2 test coverage because the majority of production was still using MySQL 2. We thought about trying to run half of our CI workers with Trilogy and the other half with MySQL 2, but we were worried that a failing test might get re-enqueued with a different worker using a different database client and pass, making it difficult to spot bugs. So that was a no-go. In the end, we went for kind of the simplest route, and we kept our tests running fully against MySQL 2 and just like manually ran CI against a branch running Trilogy daily for the duration of the rollout period to ensure compatibility. So next, we scaled Trilogy up to run on 100% of a single cluster. We were able to compare Trilogy's performance to MySQL 2's by comparing metrics on that cluster to our other clusters. We saw some pretty significant results here, which was really exciting. So this graph shows request time. The top line is MySQL 2, the bottom is Trilogy. So MySQL 2, we were seeing an average request time of 3.46 milliseconds, and Trilogy was showing on average 2.7. So about a 22% speed up. And then looking at MySQL query time, MySQL 2, 1.49 milliseconds per query, Trilogy about 1.24. So roughly 17% faster, which was very exciting for us to see. So we saw no issues running Trilogy at 100% on one of our European clusters for 24 hours. So we decided to take the plunge and roll it out to 100%. We also shipped all of our test changes at this point so that our test suite was running fully against Trilogy instead of MySQL 2. And the rollout was successful. So we were running Trilogy in production, but as previously mentioned, our final goal was to upstream the active record adapter for Trilogy to Rails so that Rails would support Trilogy out of the box. Getting Trilogy into Rails was important to us for a number of reasons. Firstly, it meant that more people would understand and share ownership of the adapter code. Secondly, it meant that we could run all of the Rails adapter tests against Trilogy, ensuring better test coverage without having to duplicate every test into another code base. And lastly, it reduced the risk of the Trilogy adapter deviating due to changes in the abstract MySQL adapter class in Rails, because everything would be together in the same code base. So once our monolith was running Trilogy in production, Shopify began working with the GitHub folks to make the case for upstreaming the adapter to Rails. As we discussed earlier in this talk, the Trilogy adapter originated as a standalone gem, open sourced by GitHub alongside the client library. The gem itself is fairly lean. There's a Trilogy adapter class that inherits from Rails' abstract MySQL adapter and contains all the core logic for the adapter. There are a few other modules defined in the gem that allow Trilogy to integrate nicely with Rails. For example, there is a DB console module that ensures the DB console command works out of the box for Trilogy. There's also a connection module that ensures that active record can recognize the Trilogy adapter. Now you might be wondering, okay, so wasn't most of the work to upstream Trilogy just copy pasting code from the gem to Rails? Yes, it mostly was, but to be fair, there were some other changes we needed to make to integrate the Trilogy adapter into Rails. First, we modified the active record rake file so that all abstract MySQL adapter tests would run against Trilogy. Some of the tests were fairly MySQL 2 specific, so we generalized them so that they would test against both MySQL 2 and Trilogy. In running the abstract MySQL adapter tests against Trilogy, we realized that there were a couple of features that Trilogy was missing to match MySQL 2 and the abstract MySQL adapter's API fully. For example, Trilogy was missing support for additional options on the explain method, so we went ahead and added this. And then finally, we added an option for Trilogy to the database generator so that applications can use Trilogy out of the box. We also added a build for Trilogy to build Kite so that CI would run the Trilogy tests. And then once those initial PRs had been merged, we were able to move on to some cleanup work afterwards. One such example is getting rid of redundant tests from the Trilogy test suite in Rails. There were some leaky tests in the Trilogy test suite that we realized were duplicating functionality tested by the abstract MySQL test suite. Initially, we just ported everything over to kind of reduce the complexity of the initial PR, but we realized that these tests were just redundant, so we went ahead and removed them. We also extracted a bunch of the shared database statements code between MySQL 2 and Trilogy to a shared abstract MySQL database statements module. So that was kind of a nice cleanup that we were able to do. And then finally, the Trilogy adapter had a number of custom error classes and its own translation logic to turn those DB client errors into active record errors. Again, we ported those error classes over in the initial PR, but soon realized that they didn't have a lot of value and that it was better to have Trilogy raise generic active record errors, just like any of the other adapters in Rails. So we worked on a PR to remove those custom error classes for the Trilogy adapter. So that is the story of our journey to migrate from MySQL 2 to Trilogy at Shopify and subsequently to upstream it to Rails. As mentioned, Trilogy is available out of the box in Rails 7.1. At the beginning, I mentioned that embarking on this journey was difficult because the path up the mountain was unclear. My hope is that you can follow the path we've made and learn from our experiences. So go forth and give Trilogy a try confidently in your Rails applications. Thank you all so much for coming to my talk and being here. I would also like to extend a huge thank you to these wonderful people who helped with Shopify's journey to adopt Trilogy and who helped with the upstream efforts. We couldn't have done it without them. If you'd like to learn more about Trilogy or have questions or comments, please come find me and say hi. I'd be happy to chat. My socials are on the slide there as well. And then I have a list of any PRs that I referenced or any kind of windows I showed can be found there. And there is a QR link to my slides if you'd like to see them. Thank you.